The phenomenon of stars producing sound is a fascinating concept in astrophysics related to the oscillations and waves generated within stars. In reality, stars don't produce sound waves in the traditional sense, but their vibrations and oscillations can be analyzed as sound waves. This phenomenon is studied under a field known as asteroseismology. Asteroseismology is the science that studies the oscillations of stars. Stars, being massive gaseous objects, undergo numerous oscillations and vibrations in their different layers. These oscillations are caused by internal processes, especially the heating from nuclear fusion and temperature and density variations within the star's layer. These oscillations generate pressure waves that propagate across the surface of the star. These pressure waves are similar to sound waves produced by the vibration of the musical instrument, but at much lower frequencies that are not audible to human ears. The sound waves within stars differ from those in environments like Earth's atmosphere. On Earth, sound waves travel by compressing and expanding molecules in the air. In stars, sound waves travel as pressure waves through hot gases and plasma. These waves get trapped in the star's interval layers and reflect off its surface. The oscillations of stars contain a wealth of information about their internal structure. By analyzing these waves, astronomers can gather the following data. Internal structure of the star. Sound waves traveling through a star pass through different layers. Changes in wave velocity indicate various internal features such as density, temperature, and chemical composition. Age and evolution of stars. The intensity and frequency of oscillations depend on the size and evolutionary stage of the star. Young and old stars exhibit different oscillation patterns, which can be used to estimate their age and evolutionary status. Mass and radius of stars. Sound waves are directly related to the mass and radius of a star. By measuring these waves, scientists can accurately determine these characteristics. How star sound waves become audible? Although the sound waves generated in stars have frequencies far below the human hearing range, scientists can use techniques to convert these frequencies into audible sound. These frequencies are typically collected as numerical data and then transformed into sound that humans can hear. This process is known as the translation of seismic data into audible sound waves. For instance, massive stars like the Sun have oscillations that naturally occur at very low frequencies, which are inaudible to us. However, by shifting these frequencies into the audible range, the sound can be heard as deep, resonant vibrations. The Sun, being the closest star to Earth, has been studied extensively in the field of asteroseismology. The Sun naturally produces pressure waves that move through its layers. Using special instruments like the Solar and Heliospheric Observatory, scientists have measured these waves and converted them into sound. The sound of the Sun resembles a deep, repetitive hum. In conclusion, stars don't produce sound that can be directly heard, but their oscillations lead to the generation of pressure waves which can be converted into audible sound waves using scientific techniques. These seismic studies provide astronomers with deep insights into the internal structure and characteristics of stars, enhancing understanding of their formation, evolution, and behavior.